husband, he is alive. He wasn't there at the time. I understand she was on her way home, got out of the car. I guess they saw the tornado. We don't know because she's passed away, but she was trying to get in the house basically when that happened. You can go ahead and roll it again now if you'd like. Thank you so much. But anyway, this is why we're all here. You know, we're not here to geek out over the radar. We are, yeah, but we got to remember that there are people's lives here. And if you were here, was it last year when James Mann from Birmingham was here? You know, he was talking about the Alabama tornadoes in 2011, you know. He's the one, if you could pause it again for me just 1 second. He almost goes into a sermon because about all the people that died in 2011, you know, and he goes through, this is unacceptable, you know, and, you know, he's passionate about this. He's passionate about, we're here to save lives, you know, and so I just want everybody to remember, weather's a fun, fascinating thing to watch, but we're here today because it's called Severe Weather Awareness Day, and the biggest reason we're here is to save lives. Now, I'm sure the lady there knew the warnings, probably had a radio on, she probably even saw the tornado. Sometimes maybe there's nothing you can do. You're getting out of your car trying to run into your house, you know. But, you know, the more people that are aware, the more people that know what's going on. One of the greatest things that I think we have now is the new, you know, emergency alerts on your phone, okay? Because no matter where you are, those things are going to go off. They're using the cell phone towers, so they're trying the polygon. Now, granted, if you're on the edge of a polygon, like for example, I live on the Sumner County, Wilson County line, and occasionally my phone will be on a cell phone tower on the Sumner County side of the line, and the tornado warning's for them, and my phone goes off and it's not me, or vice versa. You're still awfully close, okay? It's trying to use the polygon instead of just going off for an entire county, okay? By the way, you may have heard that new metro sirens, just here in Davidson County, Mayor Briley, just a couple of weeks ago, 3 weeks ago, they're actually going to put the money into what many of us have been pushing for years, particularly David Drobny there with National Severe Wicks in the back. Yeah, the big tall guy acting like nobody's looking at him, but if you don't follow National Severe Wicks on Twitter, you should. And David was a huge contributor to trying to, and Councilman Rosenberg, the Metro sirens in the near future, they're going to upgrade to where they use the polygon. That's the tornado warning. You see the little box. It's real simple. When the tornado warning comes out, the box has GPS coordinates for the four corners of it. And I thought years ago, why can't somebody just make a computer program that says if the siren's GPS unit is in that box, it goes off. If the siren's is not in the GPS unit box, it doesn't go off. Well, it costs money. And finally, Metro Council had done a study on this. They had looked into doing it, but the money just wasn't in the budget. Well, they decided the other day they were putting out some emergency money from funds for the police and the fire department, and it's not just the sirens, there's other stuff for the police and the fire department going into this, but the sirens will be upgraded to where if there's a tornado warning in Jolton, and only Jolton, but you're down in Antioch, your siren will not go off. It'll only go off if your siren is in a polygon. Okay, that might create a little confusion at first, but I think, hey, they've narrowed it down to where they can use this polygon box, let's use it. So anyway, I got off on a tangent there, but I also want to talk about radar now. We'll geek out about a little radar here. And one of the things that many of you here are old enough to remember, some of you aren't, but in 1995, the next red Doppler radar came along. And all we had before then, and I'm an old fart, so I remember when we had very little when it came to radar. And when the next red came along, suddenly you could really spot tornadoes. And as many of you know, most of our tornadoes in Middle Tennessee don't come from the classic discrete supercells. And I'll go on to tell you what that's talking about. Go ahead and roll the video there. And that's the actual tornado. You see the green next to the red. We put the little scope on there, and that's where the actual tornado is being circled right there. Okay, and it's crossing I-24 just as I showed you. Now, as this continues here, I guess I gotta let my video continue, then I'll click ahead. Let me see if I can do that. Yeah. When we have discrete supercells, and I'll show you, they're easy to identify. They're those fan-shaped ones with the classic hook echo in the back, and everyone loves to talk about them. Well, you don't need a meteorologist to tell you where the tornado is when you have a discrete supercell. It's real simple. But most of ours are embedded inside of a line or a cluster, much more complicated to see. Here's a supercell. Remember 1998? Where's the tornado? Duh. It's right where the hook is over in Nashville. Easy. Here's the Gallatin tornado when it was going through Aston City. Where's the tornado? Duh. Right where the hook is there approaching Aston City. Here's the unfortunate Super Tuesday tornado that luckily lifted when it went over Davidson County there, as it killed, I believe, 21 or 22 people in Macon County, as you know. Might have been the worst disaster in American history if it had been on the ground going through Davidson County. But that, again, discrete supercell, where's the tornado? Duh, right there where the hook is. Well, where's the tornado in this one? Anybody want to try to guess? Well, you know where it is because you've seen the video. But take a look at the big cluster of storms out ahead of that other cluster of storms and see if you can figure out where that red and the green, where's the hook? Well, there's sort of something that looks like a hook down there to the bottom of the picture. Well, yeah, look at that hook down the bottom. Oh, it's way up there. I brought this to AMS conventions. If everybody pick out where you think the tornado is, and then I go, and they go, oh. You know, before the next red came along, we didn't have this. And somebody was a genius in Washington, D.C. with the National Weather Service. So I'm just giving you kids that weren't around watching this in 1995, man, you don't know how big a deal this was. And of course, now that it's dual pole, to give us that debris signature we were talking about, again, I'll go back and forth just to show you a little close-up view there. But anyway, maybe there's a little bit of a hook right in there if you look closely, but that's just not easy to see. Now, I thought I'd give you a little bit better picture. Unfortunately, those blurry pictures, I, for my birthday, got GR Analyst 2. This is what Katie gets to hear me rant about, because she and I both love looking at this stuff. And this was a picture, and Sam will show you a bunch of these here in a minute. And there's the red next to the green, the Murfreesboro tornado that's just about to cross the interstate. And a little bit more of a clear picture. I just wanted to show you that just to give you a more clear picture to see what you're looking at. But still, if you look where that red next to the green is on the right, and then you look off to the left picture, which is the reflectivity, you know, it's pretty hard to pick the tornado out. And most of our tornadoes here in Middle Tennessee are like that. You're just hard to pick out. So thank God for whoever invented the next rad Doppler radar. You know, it might seem like an old dinosaur to some people, but man, it's a lifesaver. And it has been. Anyway, we also have a quick little video, if you could roll that one before I'm finished. Sam will show you some more of these, but I just this morning recorded a movie off my GR Analyst 2. It's a software that you can download archive data from the National Weather Service. You can do live data too, but I like to download the archive data to do historical things for AMS talks. And if you can get that to roll here in a minute, it's just a quick little animation that it's a little clearer. Because we actually had maybe 3 tornadoes in all. We had that one that was up near Smyrna that was going to go toward Wilson County, and the people in Gladeville at the racetrack, which was still being used back then, were taking cover. We don't know if that one ever touched down. But besides the Murfreesboro tornado, there was another one that actually did touch down just to the south, and it crossed I-24 just south of Murfreesboro. Luckily, there was no injuries or fatalities associated with that one. So if we can't get to play, that's cool. It's one of the ones that says GR. There we go. But anyway, if you look, you can see the obvious one, that's the Murfreesboro tornado. But if you look a little further to the north, there was another little red-green couplet go by. And in the last frame, there's one down the bottom of the screen. That's the one that actually did touch down also. It went across I-24 south of Murfreesboro, as you can see. And it has a little bit of a hook trying to show up to it, as you can see down in the bottom left part. So anyway, that's the little bit better, a clearer picture of those particular tornadoes on that day. But I want to go ahead and, let's see, catch up on time. I think a quick question or two, and I want to get to Sam, because Sam's going to give you a really deep analysis on this from the National Weather Service. Anybody have questions today about this? I explained it that well. Well, anyway, Sam Schemberger, are you in the house? Sam is with our local National Weather Service here, and I think most of you know who he is. And believe me, we've got some extremely knowledgeable people at our National Weather Service office. Larry Renozzi is our meteorologist in charge, Chrissy Hurley, the severe warning coordinator, and then of course Sam and, get a name off, Brittany was here earlier. She helped coordinate this as well. And you just don't know how intelligent and smart these people are. And we in the TV industry love NWS Chat because we can bounce off things to them because we're wondering, do we really know what we're talking about here? And Sam and somebody like that will answer it for us and give us what we need to know, and it helps keep you safe. Thank you so much.
I ain't that smart. Before we get started with my presentation, I just want to give a quick shout out to Ali Skywarn. Did y'all see him this morning? That's the NWS mascot, the big owl. That's Brendan. He's our newest forecaster at the National Weather Service. He's there in the back. And he was sweating like you don't want to know in that costume for 3 hours this morning. So give a round of applause to Brendan back there. He's my hero for today. Anyway, I wanted to take what Davis talked about with the Murfreesboro tornado 10 years ago and go more in depth about the meteorology of what happened that day, because it was actually a pretty unusual event as far as the meteorology. So let's see here. All right, So even though we're all focused on the Murfreesboro tornado that day, this was actually part of a big tornado outbreak that affected multiple states: Kentucky, Tennessee, Alabama, Mississippi, Georgia, South Carolina, and North Carolina. A big tornado outbreak. So it wasn't just Middle Tennessee that was affected that day. It was a big swath of real estate. The only strong or violent tornado here in Middle Tennessee that day, which means EF2 or stronger, was the Murfreesboro tornado. So that's kind of unusual. We had 9 weak tornadoes, which are EF0s or EF1s, and then this one massive one. And that one massive one, like David said, caused 2 deaths and a lot of injuries there in the Murfreesboro area. And another weird thing about this outbreak is it started early in the morning, like 10:30 in the morning. You know, you think of most tornadoes, when do they mostly occur? Late afternoon, early evening, when the peak heating of the day occurs. But this one started in the morning, through the midday, and ended early in the afternoon. So here's a map of all the tornadoes that occurred in Middle Tennessee back on April 10th, 2009. So the outbreak actually began in West Tennessee and West Kentucky and then spread eastward and southeastward through those states I mentioned before. So we had 3 EF1s up in Humphreys, Houston, and Dixon County in the morning, another EF1 in Sumner County, and then we had the bigger stuff down in Rutherford County. And not only the big tornado, but like Davis mentioned, the tornadoes south of Murfreesboro, one in Cannon County, one in Putnam and Cumberland County, and then one down in Coffee County. So here's a radar loop of the whole outbreak in Middle Tennessee. And all the little boxes you see there on the screen, all the red boxes are the tornado warnings that we issued that day, and all the yellow boxes are the severe thunderstorm warnings we issued. So you can see it's just blanketed with warnings. So all of these thunderstorms that day were severe. So you can tell that this was a very unstable, very highly volatile environment that day that led to the severe weather, not only in Tennessee, but also all over the region. And once the tornadoes left Middle Tennessee during the afternoon, they continued well into the night across Georgia and the Carolinas. And this is a radar loop of the Murfreesboro tornado itself from our TBNA radar. Now, this is not a National Weather Service radar, this is an FAA radar, but we're able to use it for our own weather purposes, and it shows the Murfreesboro tornado in more detail. So this is the velocity image, and right there north of the Murfreesboro dot, the tornado's in progress. So the green colors are all winds blowing towards the radar, which is located in Nolensville, right about there. And the red colors are all winds blowing away from the radar. So where those colors meet and they're real tight, that's where the tornado is in progress. So I'll let that loop through again, and you can actually see the tornado begin in southwest Rutherford County, and then it tracks up through the Murfreesboro area before dissipating. So right here is the tornado in progress as it's approaching Murfreesboro, so you can see it right here. And it's about to cross the interstate, move through the north side of Murfreesboro, and then dissipate off to the northeast. All right. So here's the full path of the Murfreesboro tornado. Everybody focuses on what happened in the city, but the track was actually almost 25 miles long, and it stretched across most of Rutherford County. So there were lots of areas outside of Murfreesboro that were also impacted by this very large EF4 tornado. So the tornado began north of Eagleville along Highway 16 there, and it rapidly strengthened, and it moved through this highly forested area here in western Rutherford County. And I don't have a picture of it here, but it literally mowed down the forest in that area. In some places, every single tree was blown down. And then the tornado, as it approached Murfreesboro, it actually weakened a little bit, and it was only causing EF0 to EF1 type damage. But then as it approached the interstate and crossed the north side of Murfreesboro, you saw in Davis's video there, it really enlarged, it really strengthened, and then it started producing EF3 and EF4 level damage as it crossed Murfreesboro. And you can see here at the end, as it approached Las Casas, it started turning to the east. And I don't really show it here, but it actually, right before it dissipated, it turned to the southeast. So it took like this big hook right at the end before it dissipated. Kind of interesting there. But a very long path here across Rutherford County. And the path was so devastating in northern Murfreesboro, you could actually see it from space. So this is a satellite image in the Google Earth program that shows the track of the Murfreesboro tornado for about a year later. So you can see right here, these are all the homes and the trees that were blown down. And you can see the scar of damage here stretching from the Barfield area up across. This is I-24 right here. This is Interstate 840 right here. And here's downtown Murfreesboro. And this is the Stones River battlefield. So here's where the tornado crossed the interstate, went just north of the hospital here, and kept on going across the north side of Murfreesboro. So it did so much damage, you were able to see the path from space. That's pretty incredible. So this video here, a member of the public, they were on Interstate 840 going westbound. So they're looking at the